welcome to my final project presentation on Amazon CloudSearch. This is Prakasha Mudalagiraiah for class CSCI e90 Cloud Computing from Harvard University Extension School. When we ask ourselves what we mean by providing search as a service or application, we mean it as retrieving information from large selection of data based on matching some items that we are interested in with each of the items in collection and returning to us those document items that contain those search terms in a desirable output order. So what is Amazon CloudSearch? Amazon CloudSearch is a managed service in the AWS cloud that makes it simple and cost-effective to set up, manage, and scale a custom search solution for your web search, website, or application. As far as the advantages go, it's very simple to set up Amazon CloudSearch. We can easily configure and manage Amazon CloudSearch with Amazon Management Console, Amazon CLI, Amazon SDK. You just have to point at the sample data and Amazon CloudSearch will automatically recommend how to configure our domain indexing options. So we can easily add or delete index fields, and we can also customize search options such as highlighting, faceting, other options. You can actually design search service without really having a good understanding of the hardware requirement is the best part. So the scalability, in my opinion, has been a powerful feature that Amazon CloudSearch is offering. So as the data or the file volume changes, Amazon CloudSearch can scale your search command resource up and down as you need it. You can also control scaling. If you know that you need more capacity for bulk uploads or expecting a surge in search traffic, you can also increase and make a control scaling. Amazon CloudSearch is reliable. It provides automatic monitoring and recovery for our search domains. If multi-AZ is enabled, the Amazon CloudSearch provisions and maintains resources for the search domain in two availability zones, which actually ensures high availability. So updates are automatically applied to the search instance in both availability zones. Search traffic is distributed across both availability zones. We can expect low latency and high throughput performance even at a large scale with the dynamic scaling that happens with Amazon CloudSearch. Hardware and software provisioning, setup and configuration, software patching, data partitioning, node monitoring, scaling, data durability, everything is handled at Amazon Cloud. Of course, Amazon CloudSearch is cost effective. You pay for what you use, the amount of data you store. Again, it's very secure. You have all the security features of Amazon associated with CloudSearch. It offers rich search features such as query search, Boolean and facet search, autocomplete suggestions, field weighting, geospatial search, highlighting, supports 34 languages, customizable relevance ranking. Before designing, it's very important that we understand the CloudSearch architecture. It's essential we also learn about concepts called search domain, which is key in terms of designing CloudSearch application. Search domain can represent data, hardware, software. It is all required to run search engine. As you can make out from the architecture, you have services, configuration service, document service, search service to work with this search domain. Configuration service allows us to create search domain with required index configuration options, scaling options, text analysis schemes, suggesters, expressions. When we create search domain, we have two important endpoints. One is document service endpoint, and another one is called search endpoint. So with the document service, we should be able to upload documents. So in brief, document service is used to make changes to domain searchable data. Data should be in JSON or XML format to upload. Search service handles search and suggestion requests for the domain. As mentioned, each domain has a unique search HTTP endpoint. When we send a search or suggest request, the search service returns a list of matching documents. So there again, the output format could be JSON or XML. Search instance associated with search domain is capable of scaling based on the data and traffic. Conventionally, it's very challenging to configure typically master and slave kind of servers to meet the scaling requirements of search solutions. But that problem is very clearly addressed with Amazon CloudSearch. As the amount of data in the search index grows, Amazon CloudSearch automatically scales the search domain as required. When the index exceeds beyond the capacity of the current instance type, the domain scales to the next large instance type automatically without any disruption to the search service that's being currently in use. If the search index exceeds the capacity of the largest instance type, the CloudSearch partitions the index across multiple instances. Again, the converse is true. If the index shrinks, the CloudSearch scales your domain down to fewer partitions and to a smaller search instance type. Amazon CloudSearch also automatically scales to handle requests in the amount of search traffic. In the search instance nears its maximum query load, CloudSearch deploys a replica of the search instance. Conversely, when the search traffic drops, Amazon CloudSearch removes unneeded replicas to minimize the cost. This way, Amazon CloudSearch determines the size and the number of search instances required to deliver low latency, high throughput search performance. It's equally important we understand data before we design such applications. Let's understand what we mean by document. Each item that we want to be able to receive as a search result is represented as a document. Again, we need to format our data into JSON or XML format before we upload to our search domain for indexing. Each document that we add to the search domain has a collection of fields that contains data that can be searched or returned. So each document must be represented by a unique document ID, and at least there should be one field associated with each document. In domain configuration, we define index field of each of the fields that occur in our document. We cannot upload document that contains unrecognized fields. However, every document doesn't have to have all the fields. Documents can probably have a subset of fields configured in the domain. there are many index field types. Some of the common ones are like text array, date array, literals, array, double array. You can also configure fields like say highlight enabled, facet enabled, filtered enabled, search enabled, sort enabled. So the user experience really depends on how this index field configuration happens. You can also specify analysis schemes for these fields, for example, synonyms, stemming dictionary, stopwords, algorithmic stemming. These additional features enable a better end-user experience with search. Just a quick note, when we add fields or modify existing fields, we must explicitly issue a request to re-index the data after we complete configuration changes. Configuration service is a key for data architect who would be configuring different type of index, mainly around search domain. We create document batches which actually describe the data that we want to upload or make changes to Amazon Cloud domain. Document batch is a collection of add or delete operations that represents the document that we want to add, update, or delete from our domain. It can be described in JSON or XML format. When we upload document batches to a domain, the data is automatically indexed according to the domain's index options. The field specified in each document must correspond to index fields configured for that such domain. However, a document does not have to contain every configured index field. When we send document updates to search domain, Amazon CloudSearch automatically updates the domain's search index with this new data. We don't have to do anything for the updates to be indexed. We can submit document batch to a search domain using Amazon CloudSearch Search Console, AWS CLI, or by posting it directly to domain document search service endpoint. In fact, the console, Amazon console, can automatically convert CSV files, PDF files, HTML, document, Excel, text, all these files into the required JSON or XML format and upload as document batches. Document service provides the ability to upload documents in batches to the search domain. It's very important we remember that if we change the configuration of our search domain index fields or text options, then we have to explicitly rebuild the search index for those changes to be visible in search results. Because rebuilding the index can take a significant amount of time, if we have a lot of data, we should first finish making all the configuration changes before re-indexing our documents. I also want to update. Document batches at this point of time are limited to 5 MB per batch. If we have to update more, a significant amount, we have to upload batches in parallel to reduce the amount of time it takes to upload all of our data. Search service provides different capabilities for query search with different way of restricting, controlling output. It is very convenient to use AWS SDKs or AWS CLI to submit such requests. SDKs and AWS CLI, they handle request signing and provide easy way to perform all the cloud search actions. We can also use cloud within the Amazon CloudSearch console. We can use search tester to even search our data, browse results, see the generated requested URLs and the response in JSON or XML format. Here, we can use any method to send HTTP request directly to our search domain search endpoint. It can be a direct URL in web browser, or you can use curl, or you can use any programming language with HTTP calls. To specify what kind of search criteria we want, we can actually add query strings that specify constraints for our search and what we want to get back in the response, and that way we can control the output we will be receiving. The search tester in the Amazon CloudSearch console actually enables us to submit sample search requests using any of the query parsers. So there are 4 query parsers that's available: simple, structured, Lucene, and Max. Commonly, simple and structured can be used, very friendly to use. By default, the results are sorted according to automatically generated relevance score. We can also control the search query for selected queries, or say to highlight the result sites to get more specific categorical information using facet information. We can also make suggestions, so autocomplete suggestions. So these are some additional capabilities with a query we can use to get more information. It's also important we understand that we can control the search results. We can actually control the sorting, changing the relevance field itself, the relevance for specific fields. We can customize the relevance. We can change the expressions, and make decisions based on the expressions. All the cloud search management tasks can be performed using AWS CloudSearch console. Here you can access all the 3 service endpoints. CloudSearch can also be accessed using CLI command line interfaces, so you can pretty much set up anything you want in CloudSearch. Just to summarize, in this project, I was able to go through and understand CloudSearch architecture, created a CloudSearch domain, understand the importance of creating a CloudSearch domain, preparing the data to upload into the search domain, understand scaling, how and when it happens, and controlling what kind of display the end user should experience, which is again can be configurable using CloudSearch services offered. The demo with sample IMDb data is not captured in the presentation. It is actually documented in another document, but the tools are very intuitive, very simple to use, very straightforward. Well, that's pretty much for this presentation. Thank you.